Hey, welcome back. This is another Shoptalk episode for December 2019. And I have a follow-up to the slow-speed carbide grinder with a ceramic lap, some shop organization. I got rid of a machine. I finally finished my hydraulic press and some smaller stuff. So let's get right into it. Here's a follow-up to my slow-speed carbide grinder that I showed in the last video. A lot of you have chimed in and found very similar ceramic discs on eBay, either by Googling or searching for alumina disc, or they seem to be used as filters, as a very fine filter in chemical processes. So if you're interested in finding something similar, look in the comments under my last video about the slow-speed carbide grinder. People have put some links in there, some descriptions what to look for, what they could be, and yeah, you will hunt them down if you really want one. So I took this disc and I machined a piece of sheet metal. This is 2mm mild steel. Faced it on both sides on a magnetic chuck, and I super glued using some rubber reinforced super glue. That's the stuff I have here. Freeze frame it if you want. There is also I think it's Loctite 380 Black Max, for example, what Robin uses a lot. This stuff, I get this on Amazon. It's super cheap, but it holds like crazy, and it's very resistant against shock. I just super glued the ceramic disc onto the steel backing plate here, and this will allow me to just put it on the magnetic faceplate of the slow-speed grinder. Okay, got the ceramic lap mounted, and I put some 1 micron diamond paste on it, and some WD-40 just to make it a little bit, to make it move around a little bit more. And I put some work into this CCMT insert that I have on my chamfer and face tool, and the results are spectacular. I get a true mirror finish on the carbide. But we'll take a close look in a second, and it's not crazy fast that way, but the finish is really good. I took an acid brush and cut it down, so I have something to spread out the diamond paste. And the cool thing is, you want to lap against the cutting edge. And the ceramic lap is hard enough so the carbide does not dig into it. You could, if you really forced it, you could dig into the ceramic, but with reasonable pressure, it doesn't happen. Especially compared to an aluminium or cast iron lap, where it's very easy to dig in. So, for example, if you want to lap the front radius of the tool, it's that easy. Or the side radius here. Go a little bit beyond 90. And that's the lapping. That's all that's to it. I really have to thank Robin Renzetti for bringing, let's turn this off, for bringing the ceramic lap to my knowledge and to public knowledge, to be really, really useful tool if you have to use solid carbide tooling that you sharpen or resharpen yourself. Let's try this carbide scraper blade. will keep one side lapped with the 1 micron diamond and the other one with the 1500 grit diamond wheel. Okay, close-up view of the scraper blade. The lower face here is lapped with 1 micron diamond, and this upper surface is ground with the 1500 grit diamond plated wheel. And you can see definitely a difference. When you lap the face of a scraper blade, you don't have to do the whole insert. It's enough if there is a band that's lapped close to the cutting edge, and it goes all the way up to the cutting edge. And this scraper blade will perform excellent. Look at this. This one will also cut perfectly fine, but this side will last longer and leave a nicer finish. It's really hard to film reflective surfaces. This is the lathe chamfer tool that I did previously, and as you can see when I go in here with a toothpick, this is really a decent finish. It's nice and reflective. And you can see here that there is a crack in the carbide. And that's my fault, because when I made this tool, I did what everybody does. I nicked the carbide and then I broke it off with a hammer, and that fractured the carbide lengthwise. So in my mind, I don't do this anymore. It's pretty bad practice to snap the carbide like this, because things like this can happen. Here's the CCMT insert that I diamond lapped here. Also nice and reflective. We're at the lathe, and this is as close as I dare to bring my camera into the lathe. And this is a piece of drill rod. 12210 is the material number. Cold working tool steel. And let's add some cutting oil. We're running 2000 RPM at the feed of 30 micron per rev. And we're taking a depth of cut of, let's see, 250 microns. So we don't get a highly reflective finish, but a very, very even finish. I'm in the process of reorganizing my die grinder tooling, and this is what I came up with. I have a new tooling cart here in the shop, and I dedicated one drawer only to die grinder tooling and accessories. So before that, I had all my die grinder tools in these boxes with the flip up lid, and instead of buying something new for this drawer, I just removed the flip up lid, and I'm using these now in this drawer. And it's sorted. I have my Kratex rubber abrasives here, from fine to coarse, disc and stick shape, some felt bobs for polishing, which I don't use very much. Here in the center, I have 3D printed inserts for these boxes with 3mm holes that take all my carbide burrs, my diamond tools, stones, brushes. I have some small flap wheels for the die grinders. Over here I have cutoff wheels and their shank. Spare stainless wire wheels, nylon, natural brushes, a shank for the, oh, this goes here, shank for the stainless brush, some larger 6mm shanked aluminum oxide stones, collets for my Proxon die grinder, for a large electric die grinder, for the Biax air die grinder, and for the flex shaft motor. So, a drill chuck for one of the grinders, large 6mm shanked burrs. These are those that are just flapping in there, are used and chipped. I use those for really bad work. Super cheap diamond tools from eBay. I use those, for example, in the milling machine to do radius grinding in carbide. Used spare 3mm shanked carbide burrs. Here I have the 3M Rolock discs that I use in my large 90-degree air die grinder. I have the normal sanding pads. I have different grids of Scotch-Brite wheel. I have these flap wheels from Tyrolit. These work exceptionally well. I have some bristle brushes, bristle wheels, and one of those very hard cleaning discs, which is also an abrasive that's plastic bound. I'm not too sure about those. I'm not too happy with them. Back here goes along with the flex shaft motor. This is a deep profile filer. Tool and die guys will know this thing. You hook up a flex shaft to the end here, which drives it. I can't do this with a screwdriver without hooking it up. And then you get a linear motion here on the end. And that's used for polishing, filing, deburring, especially in mold work, which I don't do very much. Here in the end you can hold 3mm shanked tooling in here, or you have this clamp assembly here, which allows you to hold, for example, a piece of polishing wood or a broken off piece of a ruby stone or stuff like that. A very useful tool, very expensive. They cost new about $1,000 if you get the flex shaft model. There are also air-driven ones which take a ton of air, and you can get micro motor versions which have an integrated motor. I might do a separate video on this thing. It's not very complicated. It's an adjustable crank in here where you can set the stroke from 0 to 6mm. There are also, it's a little bit like a tiny Biax scraper, but you cannot really do scraping work with it. It's more for polishing, stoning, filing. With a diamond file in this thing, you can do a lot. You can enlarge cutouts in a die plate or deburr stuff. Quite a nifty tool. Good to have. Prices on eBay will go up now, I'm sure. Spare tool holder for the die filer, and here are the clips that hold the flex shaft onto the appropriate tools. So that's my current setup for die grinder tooling, and when I have the cart next to my bench, I have all my die grinder tooling here at arm's reach length, and pretty effective to work that way. I'm somewhat hesitant to show these because I sell them, and I do not want to to show my own products here on my YouTube channel. These are precision ground bench stones. Robin Renzetti did an excellent video quite some time ago where he brought these to wide attention. I will link the video down in the description. Definitely check the video out if you have no idea what these stones are. And for my part, I make and sell these in the EU, so I do not ship them overseas or anywhere else outside the European Union. I make square ones. I make the regular shape with a lip that can go under the relief cut of the fence of a surface grinder, and I'm pretty positive that I'm the only one who makes these in a 45-degree configuration to get into dovetails. And I have a quick video clip where I show how I cut the bevel, how I grind it, and how they are used. So let's take a look at them. And if you're in the EU and interested in these stones, go to my website and look under products, and you will find price, drawings, tolerances I make them to, and how to order them. So yeah, let's go to the grinding. Are angled stones. I made these for myself years ago. These are just cut with an angle grinder and then ground to 45 degree. I use those when I scrape dovetails. They are 45 degrees, so you can get in any dovetail that's wider than 45 degree. This one here is even relieved because I couldn't get in. These work, but due to the short length, they tend to snag up and chatter and vibrate. It's not the ideal form. So I decided to cut one lengthwise. I will show you how to cut these stones very easily. Cut it lengthwise, and I'm going to grind this, and this will not make any problems with vibrations because it has a very long engagement, no problems there. So let's go to the machine and see how we cut those. It's surprisingly easy. I set this up on the tool and cutter grinder because I can tilt the wheel head here and clamp the vise down flat on the table. And for this operation I do not want to rely on a magnetic chuck on the surface grinder. So, because we're taking a fairly hefty cut. So bolted the vise down to the table. It's aligned to the axis of the table. And I have the wheel I'm using is a standard tile cutting wheel for the angle grinder. That's what you buy at a home improvement store for your 125 millimeter angle grinder. And just put it on a flange and centered it so it runs through. And this works like crazy. It's a metal bonded diamond wheel, and it cuts so freely. Let's take one of my own sets of stones that I'm using for myself and whack off this corner. Clamp it. I'm just holding it in the vise like you would normally any other thing that you grind. And this will create a lot of dust, so dust extraction is a very good idea. So yes, this is a very, very dirty and very used stone. It doesn't matter, even if they are dirty, they work like a charm. No problems cleaning up any precision surface with these. So dust extraction, I need a dust mask. So, as I said, this is seriously unspectacular. You end up with this triangular stone and very little mess. You saw that the dust extraction really works very good. I have to loosen this strap clamp because I'm holding the vise on the movable jaw. So, there it is. Second one cut. Takes a few seconds. Over to surface grinder. That's the setup to grind the 45 degree flat. It's not a precision angle. The angle doesn't really matter at all. I'm using one of those angle blocks that you put under your vise, and the second vise is tilted at 45. And then I just touch the surface with diamond wheel until it's nice and flat. Before we do that, the stone has to be, of course, ground at least the two large flats and one narrow side. So it's nicely referenced. Then you grind it, deburr it with diamond file, or what I do with a die grinder and a small diamond stone, and you're done. Deburring this razor sharp edge with diamond file. Same for this edge. These end edges. And balling over the corners a little bit. I'm showing this in quite a bit of detail, so if you don't want to buy them, just make them yourself. It's no magic in them. There we go. And that's the sound you're looking after. No crunchy noise, it's just smooth sliding onto each other. So when you use these stones, always make sure that the surface you're touching are clean. I like to use some denatured alcohol or acetone or whatever gets the surface clean. And yeah, this is my milling machine. It's a good way to demonstrate these. So let's say you want to stone this flat surface of the dovetail here, this one, the large flat here. Take your stone with the bevel cut on it. You make sure it's clean, as the sound indicates. No crunch noises, no sanding noises, nothing. Then you go in here, tuck, and you're good to hit the whole surface right into the relief of the dovetail. Same for this surface. For the small angled surface, you can also make sure your stone is clean, and you come in like this. Or if you want, you can come in like this and tilt it against this surface. I wouldn't recommend this too much. I think that way it's more stable. In reality, it would be okay not to precision grind this surface, but I'm giving you this surface too, for whatever reason you might need this one day. So the angled stone has also 1, 2, 3, 4 ground precision surfaces, and you get a fine and a coarse side on the wide side of the bevel. See, coarse, fine. So those who follow me on Instagram already know probably I sold the engraving machine, the Deckel G1L, because it's obsolete. Let's be real, it's obsolete. I have 2 CNC routers, one which is perfectly capable of machining steel, and I really don't need it anymore. It just takes up too much space. It's a beautiful machine, but space is rare. My shop is relatively small. My secondary shop is also relatively small, so I have to make do with the room I have. And the engraver just took up way too much space, took up this whole corner. And now this gave me a place to put one of my tooling carts, and it has a permanent place for my ultrasonic cleaner, which I need all the time, and my newly built hydraulic press, which I started 4 years ago and had recently to finish because I need it for a customer job. I have to do several hundred parts that need to be coined, and the hydraulic press is the way to go for this. We considered a toggle press, but well, a toggle press is slightly not powerful enough for the job it had, so we're using the hydraulic press. This goes up to, the cylinder is rated for 10 tons, but the math doesn't work out. In reality, it's about a 6.5 to 7 ton metric ton press, 60 to 70 kilonewtons. Okay, the press is a very basic design. Basically, that's what everybody else builds. 4 uprights, cross pins, and the table just sits on those cross pins. This parallel is currently super glued on here because I needed it for alignment of a tool that I had sitting on here. Chinese 10-ton cylinder, And I had to machine a 1/4 inch and NPT thread into it to add a pressure gauge, which is facing currently the wrong direction. But as I'm running the press from this side, it's okay. Working distance between the table and the ram is not ginormous. If I had built this press to work on electric motors, press out bearings and stuff like that, I would have built it way larger, but that's not the work I do. I need this primarily for bending, pressing, forming, and it's a hand pump. It's a two-stage pump. First stage is for quick movement, and if there is any considerable force on the ram of the cylinder, it switches over, and then you can go in a high pressure stage, and then this pump should go up to 700 bar, which I do not believe, because at about 500 to 600 bar, you already are cranking down like crazy on this thing. But it works for my purposes. I have some very old footage that I will insert. Deburring the uprights on the chamfering machine, putting a nice large 1mm chamfer on all the edges. The cross pin holes were drilled with a 20mm rotary broach or core drill, or there are many names for these, but they all have in common that they drill very clean, very precise holes exactly on location with very little power requirement from the machine itself. And also the rigidity of the machine is not that critical with these drills. These are the upper beams which connect all the uprights together, and these are large C profiles, and those are never square, and I want this press to be as square as possible for two reasons. One, when you don't have any forces coming in at an angle, you don't put any weird stresses on your welds, only pull forces. And I also want the press within itself as precise as possible, because I plan to use it for press and form tooling, and those have a basic requirement of precision. That's the setup to mill those surfaces, and as you can see, when I take the surfacing cuts, it starts at the center and it fans out to the end, because this material always has a draft angle. I had everything set up on the surface plate to get the upper beams nice and parallel to the base, everything square. Then I clamped it together for welding. Everything is TIG welded. Through drilling the holes from the plate into the frame, so I can tap them later and bolt the plate to the frame. Here I'm mounting the plate for the hydraulic cylinder. The plate only has a through hole for the cylinder. Then I have this large steel ring which has the actual thread that matches the end of the hydraulic cylinder. This bolts to the plate, and the cylinder screws into the plate. And here's the basic frame of the press finished. Looking already pretty decent. Only thing that's left are the cross pins and the support plates, which are just large plates of cold rolled steel. So that's all I have for this episode. Hope you enjoyed. Thank you all for watching, and see you next time.